So in this lecture, let's discuss radicals and rational expressions. Now, what is a radical? So let's take this expression here. Let's say, for example, I have a variable called root a. So the root here represents a radical, and the a value is called as the radicand. So the combined expression of root a is called as a radical expression. So the combined form is called as a radical expression. Now, why is this important? A radical is defined as a number if multiplied by itself yields the radicand. So a radical if multiplied by itself yields the radicand. What does that mean? If I multiply root a times root a, so multiply root a and root a, you end up with a. This root, this value is called as the principal square root. So this value is called as the principal square root. So a root a value is called as the principal square root. So this principal square root is determined by the value of the radicand. Now let's take a simple example of finding radicals of different values. So when you take under root 25, square root of 25 can be 5, can also be negative 5. Why is that the case? Try multiplying 5 with itself, you get 25. Try multiplying minus 5 times minus 5, you still get 25. So which means that the square root of 25 can be plus or minus 5. So this here is the understanding whenever you take the square root of a number, especially for a perfect square. So what is a perfect square? So a perfect square is any number that can be expressed as a square of another number. For example, 25 can be represented as 5 square or minus 5 square. So 25 here is a perfect square. Other examples of these are, for example, 81 can be represented as 9 square or minus 9 square. For example, 256 can be represented as 16 square. For example, 625 can be represented as 25 square. Right? So this way you can write multiple squares. So this is how we generally use a radicand. Let's take an example. So let's try finding the value of square root of 16. So the first thing that we have to do is evaluate the inside expression first. So the internal expression is root 16, so which gives you a value of 4. Now square root of 4 again gives you 2. So notice that when we did this, we did not take the negative value. The reason we don't take that is because the square root of a negative number is not valid, or it does not have a real number. So it is not a real number. So the square root of negative, so negative a, is an imaginary number. So we told that there are two types of numbers, real and imaginary. So we'll discuss this root of negative numbers in the coming chapter. Now what are some of the properties of these radicals? Let's discuss the properties of radicals. So the first property is the product rule. So square root of AB can be written as square root of A times square root of B. Just because this is true doesn't mean that root A plus B is root A plus root B. It's actually not equal to root A plus root B. So remember that root of A plus B is not equal to root A plus root B. Number 2 is under root A by B. A over B gives you root A over root B. So this is the second property. Now let's take a simple example of how to add square roots. Addition of roots. How does addition work? For example, let's say I have a value of 5 under root 12 plus 2 under root 3. Let's try and use the properties that we see here, and let's try and apply this to this problem. When you look at this expression, the first thing that pops to your mind should be, when you took at root 12 can be written as 4 times 3. So plus 2 under root 3. So 5 into so now root AB we know is root A times root B. So it becomes 5 times root 4 into root 3 plus 2 root 3. So which gives you 5 times under root, 5 times. So root 4 is 2 and root 3 stays the same plus 2 root 3. So 5 times 2 becomes 10. So 10 root 3 plus 2 root 3. How do we add 10 root 3 and 2 root 3 here? What we do here is we consider the same situation as that of any expression. We take root 3 out of the equation and we add the numbers. So that gives you a final value of 12 root 3. So this answer for this value, the simplified version of this, is 12 root 3. Next, let's try and subtract some numbers. For example, I have 3 under root 80x minus 4 under root 45x. Let's try this one. So notice that x is inside the square root. So first thing we have to do is 3 into under root. So again this is AB. You can split it as root 80 into root x minus 4 times root 45 into root x. So can 80 be represented as a perfect square? So let's look at the factors of 80. One of the factors is 16 times 5 and 45 can be written as 9 times 5. So write down the actual values there. So you get 3 under root 16 times 5 into root x minus 4 times 9 times 5 into root x. Now, so 3 into, again use the root AB formula, you get root 16 into root 5 into root x minus 4 into root 9 into root 5 into root x. Now, we know that root 16 becomes 4, so it becomes 3 times 4 into root 5 into root x minus 4 times root 9 is 3, so becomes root 5 into root x. Now simplify the value, so you get 12 times, notice that we cannot further simplify root 5 and we can also further simplify x. So write it as a single value, so root 5x minus, so 4 times 3 again, 12 times root 5x. Notice that both are the same values, so you can cancel each other, so with the final value becoming 0. So the final answer for this problem is 0. So this is how you can simplify roots. Now the common values of multiplication stays the same, so you just multiply the values. So let's take a simple example. Let's say I have root 5x into root 10y. So what do we do here is we multiply directly as used to root a into root b, which becomes root ab. So it becomes root 5x into 10y. So multiply the numbers and keep the variables separate. So it becomes root 50xy. Now this is the simplest one. Now let's try and go towards the complex one, which is division. How does division work? So when we are doing division, let's take a simple example. Let's say I have a value of 2 root 3 by 3 root 10. The idea is always to not have a root in the denominator. So we are trying to eliminate the root in the denominator. So to not have the root in the denominator, what we'll generally do is we use a process called rationalization. So what we do in rationalization is we multiply the value to some certain value to make sure that it does not become a root. So for example, in this, if you want to eliminate the root, the only way is to multiply itself to the value. So you can multiply and divide at the same time, provided that does not change the actual value of the variable. So now it becomes 2 times root 3 into root 10 divided by 3 times root 10 into root 10 becomes 10. So it becomes 2 times root 30 divided by 3 times 10, that becomes 30. So this is the final answer. So the other way of doing this is you can do 2 times 215, so that becomes the final value, gives you under root 30 by 50. So this is your simplification. Now what if the roots are much more complex? So let's say I have a root like this, a plus b root c. So this is the variable that I am trying to rationalize. When you rationalize the denominator here, how would you rationalize this to eliminate the root? So what we do here is, for any variable, we basically take the sign in the middle and exchange the sign for the opposite sign. So what we do here is we multiply a minus b root c divided by a minus b root c. Here a minus b root c is called as the rationalization factor. So it's called as the rationalization factor. So it becomes the final value. So let's take a simple problem. So let's say I have 4 divided by, so 4 over 1 plus root 5. So we are trying to rationalize 1 plus root 5. So the rationalizing factor will be, just change the sign in the center, so it becomes 1 minus root 5. So now you have 1 minus root 5. So what we'll do here is multiply and divide at the same time. So for this value, 4 by 1 plus root 5, we multiply 1 minus root 5 and divide 1 minus root 5. Now if you remember the common algebraic formula, this is a plus b into a minus b. So we know that a plus b into a minus b becomes a square minus b square. Notice that here a is 1, b is root 5. So it becomes 4 times 1 minus root 5 divided by 1 square minus root 5 square. So it becomes 4 times 1 minus root 5 divided by 1 minus, so roots square and root get cancelled, so you get 1 minus 5. So you get 4 times 1 minus root 5 divided by minus 4. So 4 get cancelled, so you're left with minus of 1 minus root 5. So when you multiply minus to this, you get minus into 1 becomes minus 1. Minus into minus root 5 becomes plus root 5. So the final answer is root 5 minus 1. So the simpler version of writing this variable is root 5 minus 1. So in the same way, try this example. So try to rationalize 1 by 1 plus 2 root 3. So that hint here is the root rationalizing factor is 1 plus 2 root 3 here. So just change the sign in the center. So it becomes 1 minus 2 root 3. So now try and find the answer. So try it and check your answer. So pause the video right here and try to solve this problem. So if you are done with the problem above, try another problem, 7 over 2 plus root 3. So try to rationalize this as well. So try this problem and pause the video right here. So now, so let's do the next topic, rational exponents. So what happens here is that if you take the square root of a number, square, so whenever you write under root a, it represents a to the power 1 by 2. So these are called rational exponents, which means that these are exponents that have a fractional value, right? Now you can also write other values. Can we write a power 1 by 3? Yeah, you can. For example, if you take 8 here and write 8 to the power 1 by 3, it becomes 2. Why is that the case? 8 is 2 cube. So when you write 2 cube whole to the power 1 by 3, so the 3 get cancelled and you end up with 8 power 1 by 3 becomes 2. So how would we write this in the in the form of a root? Is we basically take the bottom part of it and write it upon the root. So cubed root of a. So how would we write this? So the nth root of a is written as, so when you write the square root, you write the square root like this. And rather than writing it in the front, what we write here is between the square symbol, we write the n value and we write a. So this is the symbol of nth root of a. Now if you have just 1 on the top, it's easy to write this. But what if you have a to the power m by n? How would you write this as a expression? So this becomes again square root, n comes in the front, and in the a you write a to the power m. So this is the rational variation between the variables. So this is how you can write the rationality. Now in the same way, try finding the value of 343 power 2 by 3. So let's try and find this. So we know that we can write this as a to the power of m by n, can be written as nth root of a to the power m. So the n here, so the m is 2, n is 3. So it becomes cubed root of 343 square. Now what is 343? So how would you write the square of the cube of 343? So if you remember the exact value, so what you can also do is, because this square can be anywhere, so what you can think of it is you can write this as, so the square can come out as well, so you can write it as cubed root of 343 whole square. So cubed root of, what is 343? How would you write it as 343 here? So cubed root of 343 is 7 cube. If you remember, 7 times 7 is 49, but when you multiply 49 times 7, you get 343. So the whole square now. So cube and the square root get cancelled. So you'll be left with 7. So 7 square, which gives you the final value 49. So you require the understanding of perfect squares. So I would recommend solving more problems from the textbook. So try to solve more problems from the textbook. As you learn more and more, it will be easier to understand this particular topic.